Hi class, welcome to our new chapter, Laplace Transform. Before that, I would like to share some application of Laplace Transform in engineering field. Actually, there is so many usage of Laplace Transform, but what I'm going to share in a moment is only partially of it. Laplace transform actually is transformation or conversion from t, which is time function, to s function that will be useful in control system. It plays important role in control theory. It appears in the description of linear time invariant systems, where it changes convolution operators into multiplication operators and allows to define the transfer function of a system. The properties of systems can be then translated into properties of the transfer function. In particular, causality implies that the transfer function must be analytic in a right half plane. We shall see that several kinds of stability with different physical meaning can be considered in connection with some function spaces, the Hardy spaces of the half plane. These function spaces provide with their norms a measure of the distance between transfer functions. This allows to translate into well-posed mathematical problems some important topics in control system. So, let's go through to this chapter. There is two types you will learn in this chapter on how to convert these two functions. In the first part, I'll teach you how to convert t function to s function by using definition, table of Laplace transform, first shifting theorem and multiplication of t power of n. The second part, you will learn how to inverse the process of Laplace transform, which is the conversion from s function to t function. This is what we call inverse Laplace transform. Let's see an example on how to apply the formula. Let's say we have a as our t function. First, refer to the formula, write down the integration symbol with limit from 0 to infinity, exponent, and the t function that we need to transform to s function. Next, factorize all the elements of the constant. Here we have a as a constant, so we bring it outside. Once integrate, then this is a result. After that, put a limit. Then simplify the equation, bring out all the constant and leave the s function with its limit that is from 0 to infinity. After that, substitute t with the limit and this is the result. What happened is 1 over exponent of infinity is equal to 0. This is because exponent of infinity is a very big number. Then that's why we call it infinity. So number 1 when divided by a large number will give you 0. Am I right? Then exponent of 0 is equal to 1. Finally, this is your answer. Let's go to example number 2. Here we have our t function is equal to exponent of at. The formula, with same step as before, refer to the formula, then write down the integration symbol with limit from 0 to infinity, exponent, and the t function that we need to transform to s function. Next, because the t function is also function of exponent, so what we can do here is simplify the equation where the result is exponent of a minus s times t. Now we have exponent of a minus s times t integrate with respect to t. Once integrate, then this is a result. Put the limit here. Then repeat the same process as example before. Simplify the equation, bring out all the constant and leave the s function with its limit that is from 0 to infinity. After that, substitute s with the limit and this is the result. 1 over exponent of infinity is equal to 0 and 1 over exponent of 0 is equal to 1. Then finally, this is your answer. Okay, see you again in our next session. Thank you.